Good morning, my dear students. Today I am going to discuss tricks to solve NEET questions in the basic concept of organic chemistry. I am Dr.R.G, Professor of Chemistry, who is taking class for you. Now, before entering into the questions under the basic concept of organic chemistry, what are the topics you have to study? Number one, importance of chemistry. Number two, purification of organic compounds. Depending upon the solid, liquid, different types of methods are available. Then detection of elements, estimation of element, that is percentage of each element present in the compound. Then determination of empirical formula and molecular formula. Then classification of organic compounds based on the functional groups. Then naming of organic compounds, that is under this common name and IUPAC name. Configuration, here we have to study, there are three types of configuration we have. One is under the configuration, the Newman method, and there is Sahar's. There are three ways we can draw the structure of a molecule: Fischer, Newman, and Sahar's, that we have to study. Then RS system of configuration we have to study. Then isomerism of the particular compound we have to study. Then finally, reactions and mechanisms we have to study under the basic concept of chemistry. So these are the important topics. It will cover entire organic compound. Please follow. When we are discussing these topics, this is the common for entire organic compound, starting from alkane, alkene, alkyne, alkyl halide, alkyl alcohol, aldehyde, ketone, acid derivatives, nitric compounds, amines, cyanide, isocyanates, and biomolecules. So, let me go for now the questions asked for the last 6 years under this topic. First, question number 1, asked in NEET 16. The first question was asked in NEET 16. The correct statement regarding the comparison of staggered and eclipsed conformations of ethane is A. The eclipsed conformation of ethane is more stable than staggered conformation because eclipsed conformation has no torsal strain. B. The eclipsed conformation of ethane is more stable than staggered conformation even though eclipsed conformation has torsal strain. C. The staggered conformation of ethane is more stable than eclipsed conformation because staggered conformation has no torsal strain. The staggered conformation of ethane is less stable than eclipsed conformation because staggered conformation has torsal strain. So, these are the 4 statements given. What is they are asking? The correct statement regarding the comparison of staggered and eclipsed conformation of ethane. So, which is the correct statement? Before explaining that, let me introduce this. This question was asked under the basic concept of chemistry, specifically conformation. What is conformation? Kindly follow. A molecule having, say, that is the I can say compounds having same molecular formula, but different in configuration, in spatial arrangement, due to carbon-carbon single bond rotation is called conformation. So specific example, we can give ethane, specific example, N-butane we can give, you can even give for the hexane also we can give. That is cyclohexane. Okay, that is called conformation. Okay, let me, for your understanding, I am giving here the formula for ethane. These are the Fisher formula. According to Fisher projection, the theory I have already discussed, carbon should be written in the vertical line and groups attached should be in the horizontal line. This is the normal method. We have to represent the three-dimensional formula in two-dimensional board or notebook. So by putting simply cross. This is the Fisher projection. Kindly follow. So what you are seeing below is the eclipsed. Correspondingly, eclipse and the staggered confirmation of Newman projection. So according to Newman, so either you can view from here at the top or from here you can view the molecule. Suppose we are viewing from the top, kindly follow. So this is 1, this is 2. So number 1, according to Newman, number 1 should be pointed out, this is as a point. Number 1 carbon should be a point. Number 2 should be a circle. This is the convention followed by Newman. Number 1 carbon should be a point. This is 1. Number 2 will be a carbon will be a circle. So then we have to represent the corresponding atom or groups around the space. So here I have shown you two confirmations. One is eclipsed confirmation, kindly follow, for ethane. This is the staggered confirmation for ethane. What is the difference between these? Kindly follow. So in this case, hydrogen facing each other, hydrogen facing each other, hydrogen facing each other. Whereas in this case, hydrogen, that just see here, by simple rotation of 60 degree, you are getting this confirmation. So in this position, two hydrogen atoms are far away from eclipse. That's why staggered is more stable than eclipse. Please follow, understand this one. When you take these two hydrogen atoms, the distance between two hydrogen atoms, in staggered confirmation, they are far away. So proton or electron repulsion will be minimum, more stable. But in the case of eclipse confirmation, it is very close. So there may be the repulsion will be there. So generally staggered will be more stable. Kindly follow. This is according to Newman. So let me give one more information for you, my dear students. Fisher normally used to represent, to write the structure, three-dimensional structure in two-dimensional board or notebook. Whereas Newman projection and Sahars, that we are going to study later, these two projections to study the stereochemistry and stability of the reaction. Please follow. Now we will come for the correct answer. Kindly follow. The correct answer is C. Correct answer is C. The staggered confirmation of ethane is more stable, I pointed out already, than eclipse confirmation, because staggered confirmation has no torsional strain because they are far away. Each hydrogen atoms are far away, so repulsion will be less. That is, strain will be, torsional strain will be less. That's why staggered is more stable. My dear students, I hope you understand this. Question number 2. This is another interesting question. Kindly follow. This is asked in NEET 2016. Please follow. So which of the following biphenyls is optically active? This is the question. So they have given different compound, kindly follow, different biphenyls and substituted compound. In the first one, biphenyl, two, that is one ortho, if you take each benzene ring, one ortho iodine, another ortho Br. The second phenyl group, one ortho is bromine, another ortho iodine. In B, only one position in each cases, only iodine. In third case, in the one benzene ring, there is two methyl groups, another benzene without any substituent. Third is, kindly follow, it is missing, that is here NO2, that is one benzene ring in the meta position NO2, here is again meta position NO2. The question is, which is optically active? So, for this, what we must know, what is optically active, we must know. Then, what are the conditions to identify the optical activity? Then only you can able to understand this. Let me explain now, kindly follow. So, this question was asked under the basic concept of organic chemistry, specifically optical activity. What is optical activity? Let me define now. Please follow, my dear students. Compounds having same molecular formula but difference in optical activity. Difference in optical activity, I will explain later, are called optical isomers, and the phenomenon exhibited by this optical isomer is called optical isomerism. Let me repeat again. Compounds having same molecular formula but difference in optical activity are called optical isomers, and the phenomenon exhibited by this optical isomer is called optical isomerism. Please follow. So, what are the conditions to show optical activity? And before that, let me explain, kindly follow. What is optical activity? Let me explain. Kindly follow. The ordinary light, kindly take now. This is ordinary light, vibrates in all directions. So, when it is allowed to move through a Nicol prism, so all lights are coming and heating this Nicol prism. So Nicol prism is having a quality, it will cut off all direction except only one direction, which is perpendicular to the line of propagation. So this is the line of propagation. So this is perpendicular line of propagation. This is called plane polarized light. Plane polarized lights. Please follow. So, what will happen? When this plane polarized light, we have to pass through a tube containing solution of the compound. This is normally in polarimeter. Instrument we are using is polarimeter. So, after coming out this plane polarized light, when it is allowed to pass through the solution, there are three things happening. One is nothing is happening. In another case, it is rotated clockwise. And third is it is rotated anti-clockwise. These are the three options are there. Please follow. So I am passing ordinary light which vibrates in all direction. But when I pass through the Nicol prism, it cut off all direction except one direction which is perpendicular to the line of propagation. So this light I am calling it as plane polarized light. When this plane polarized light is passed through solution of our compound to measure as optical activity, usually a polarimeter is an instrument used. After passing out, we have to view the light. Normally, sodium vapor lamp will be used as the light source. And when you view that, if the direction is not changed, the compound is optically inactive. If the direction moves clockwise, then it is this textorotatory. That the optical, we will call it as textorotatory, normally indicated by small d or plus. If it is rotated anti-clockwise direction, it will use levorotatory or minus. So this property will call it as optical activity. Please follow. This is called optical activity. Kindly follow. I hope now you have a clear idea. Let me come for the conditions. So that is theoretical. That is experimental. Experimentally, we are determining the optical activity using plane polarized light, using polarimeter. But what are the conditions? Theoretically, if any question is asked in the examination, how to find out the optical activity or not? So what are the conditions to show optical activity? So to produce a non-superimposable mirror image, that means to show optical activity, a molecule should produce non-superimposable mirror image. What is meant by non-superimposable, superimposable? So this is an image, that is the real, this is the real image. This is the mirror. This is the mirror image. Please follow. So they are identical. You can fix one over the other. They are identical. So this is superimposable. Suppose show your left finger in front of a mirror. Then again, then right finger you can put one over the other. So that is, it is actually, now if you place right finger over the right hand over the left hand, placing all the fingers on this, then all the fingers will not coincide with the other finger, left hand and right hand. This is unsymmetrical. So if any condition arises that the way we will say non-superimposable mirror image. So to produce, if any molecule produce non-superimposable mirror image will be optically active. That is theoretical. Imagine, that is theoretical. So to produce non-superimposable mirror image, what a molecule should have? One, no plane of symmetry, no center of symmetry, no axis of symmetry, and no alternate axis of symmetry. These are the conditions it must have. Let me give examples for optical isomerism. Lactic acid. This is the molecular formula. CH3, COH. Lactic acid. Molecular formula C3H6O3. So, how can I write here? Kindly follow. Lactic acid. I can write H, OH, COH, CH3. Or better, I will write like this way. Following the Fisher projection, I will write that is better for you. CH3, HOH, this is COH. This is the lactic acid. Mirror image, kindly follow. COH, OH, H. This is CH3. Please follow. So, one is D-lactic acid, another is L-lactic acid. Kindly follow. Now, I want to give one information. This is D, dextro, small d, that is plus rotating clockwise direction. And L, levorotatory, that are minus, that is experimentally determined. And if you use RS configuration, kindly follow, this will be R. That is the correspondingly S configuration. So this is R configuration. I will come later. So the idea here it is, this is a theoretical configuration. So this same molecule, lactic acid, I am writing two different configurations. In the first case, H is left side, OH on the right side. Second case, OH is on the left side, H is on the right side. So different configuration. But when you measure is, one is rotating clockwise, another is rotating anti-clockwise. This is an example of lactic acid optical isomerism. Kindly follow. So I am introducing a new term, chirality. It's a modern term. What is the chirality? It is the essential and sufficient condition for a molecule to be optically active. So chirality arises due to two ways. One is due to asymmetry, another is due to dissymmetry. So how can I define chirality? Let me define. Optically active molecules are called chiral molecules and the center is called chiral center. Please follow, this is the most important. Optically active molecules are called chiral molecules and the center is called chiral center. So I told you chirality arises due to asymmetry, due to dissymmetry. What is meant by asymmetry? So any molecule having, suppose let me take one asymmetric carbon atom. Asymmetric carbon atom is one where four different atom or groups are attached. Specific example, lactic acid, just now I have informed you. Let me take, kindly follow, this is the method I am following. So when I am giving this method, my dear students, you understand that you can create an optically active compound for all types of organic compound. What is the method you have to follow? Write always hydrogen below. Please follow. Hydrogen below. The next you have to write correspondingly CH, kindly follow 3 second. The third is CH2, CH3 third. And fourth one, any functional group. Please follow, I am writing X. So this is, suppose if I write X equal to propyl group, it is optically active. Alkane is optically active. The name of the compound I can give here 1, 2, 3, 4, 5, 6. It is 2-methyl-hexane, optically active. So this is due to asymmetric. Kindly follow, in the lactic acid reaction there is an asymmetric carbon atom. Whenever asymmetric carbon atom is there, there is D and L. The D and L configuration are called enantiomer. Please follow. Enantiomers. They are called enantiomers. Plus and minus form are called enantiomers. So whenever one or more asymmetric carbon atom is there, one is the mirror image of the other. They are called enantiomer. So let me define what is enantiomer. Optically active compounds having same molecular formula, but one will be the mirror image of the other are called enantiomers. Kindly follow. D tartaric acid, that is plus lactic acid and minus lactic acid are examples of enantiomers. Kindly follow. The other thing is dissymmetry. What is dissymmetry? I told you already, there is no plane of symmetry, no center of symmetry, no axis of symmetry, and no alternate axis of symmetry. The molecule as a whole is dissymmetry. So there is no asymmetry. Please follow. There is no asymmetric carbon atom at all. There are compounds. I am going to discuss, but these four conditions are absent. Kindly follow. So, under this section, dissymmetry compound, there are three examples: allenes, spiranes, biphenyls. So our question is asked under this heading. Biphenyl they have asked. So what is, let me explain now. Kindly follow. This is the allenes. Kindly follow. 3 carbon double bond, carbon, CH3, HH. But you must understand that one is that is thick line, another is dotted line, means they are not at the same side, they are at the opposite side. The same way this side and this side are not at the same side. Kindly follow. Another important information, the central carbon double bond will be perpendicular to each other. Perpendicular to each other. Then only there is no plane of symmetry, no center of symmetry, no axis of symmetry. So optically active. Same way here spirenes. In spirene, instead of double bond, they have CH2 connected. Then we will come for our interested compound biphenyl only based on these questions asked. So in the case of biphenyl, many bulky group present in the ortho positions. So now that compound will be optically active because the normal biphenyls, kindly follow, this is the 5-phenyl. They can be easily rotatable, so they can be easily that is same plane. Both ring will be same plane. There may be a plane of symmetry. This is not optically active. Not optically active. So simple biphenyl is not optically active. When the optical active arises in biphenyls, when bulky groups in ortho position occupies, so because of the repulsions, so the ring will rotate such a way that one ring will be perpendicular to other ring. So automatically COH or SOH will be going on the opposite side. So there is no plane of symmetry, no center of symmetry, no axis of symmetry and no alternate axis of symmetry. But there is no asymmetric carbon atom, please remember. That's why biphenyl is optically active. So only based on this, I am going to discuss this compound. Kindly follow. Please follow. So under the NEET question 16, which of the following biphenyl is optically active? The correct answer is A. Because in both biphenyl compound, both ortho, one orthobromine, another orthoiodine, one orthobromine, another ortho. So it is repulsion high because large atoms, repulsion will be there. So one ring will be perpendicular to another ring. So this will be optically active. Whereas this is only single atom. So that they will form a planar molecule. So this is not optically active, not optically active, not optically active. Please follow. So this is the answer for these questions. The next question, 3, it is asked in NEET 2017. The suitable method of separation of 1:1 mixture of ortho and para nitrophenol is A. Steam distillation, B. Sublimation, C. Chromatographic technique, D. Crystallization. Okay, let me go for the topic under this. This question was asked under the unit Basic Concept of Chemistry, subunit the purification method, under this specifically steam distillation. What is the difference between orthonitrophenol and paranitrophenol? Kindly follow. This is the structure. Kindly follow. Phenol. This is orthonitro. This is phenol. This is paranitro. What is the interesting information here? We have already studied under the chemical bonding, hydrogen bonding. So in this case, orthonitrophenol, there is hydrogen bonding is present. Please follow. What way? O, H is there, N, double bond O, O. So there is hydrogen bonding. That is called intramolecular hydrogen bonding. Intramolecular hydrogen bonding. But this one, paranitrophenol, cannot form intra. It will form intermolecular hydrogen bonding. Inter. But we have studied already, generally, intermolecular molecules having intramolecular hydrogen bonding will having high melting and boiling point, high boiling. Whereas intramolecular will be having low melting and boiling point, that is highly volatile. So based on this only, we can use steam distillation to separate intra and that is orthonitrophenol and paranitrophenol. Kindly follow. When substances are insoluble in water but soluble in steam, can be purified by steam distillation. So there is a specific condition. They will be insoluble in cold water but soluble in steam, can be only purified by steam distillation. This method is useful to purify essential oil from plants and flowers, aniline manufacture of turpentine, etc. So this is the apparatus used for the steam distillation. There is a steam generator, it is passing everything. Okay, let me go for the next one. A specific example I have to mention here. If you take glycerol, example is CH2OH, CHOH, CH2OH. This is the trihydric alcohol, glycerol. So this glycerol, if you boil at a normal temperature, that is, the boiling point is 298, 760 millimeter pressure. But what will happen if you heat at this particular temperature? This will decompose. Decompose means water will be eliminated. Water will be eliminated, will becoming charring. You will not get glycerol in pure form. But instead of that, kindly follow, by distilled under reduced pressure, specifically you follow this, that is at 12 millimeters of mercury and 180 degrees centigrade, this can be distilled without decomposition. Same thing, sugar cane also. So now come our questions. Please follow. So the suitable method of separation of 1:1 mixture of ortho and para-nitrophenol is due to steam distillation. Please follow. Only because orthonitrophenol is a very highly volatile, easily comable. It will come out first, then second only the para-nitrophenol. So you will collect separately orthonitrophenol, you collect separately para-nitrophenol using different receiver. So we can easily separate by steam distillation. Question number 4. This is the question asked in NEET 2017. The correct increasing order of basic strength for the following compound is A. 1 aniline, 2 para-nitroaniline, 3 para-methyl aniline. There are 4 options are given: A, B, C and D. Kindly follow, my dear students. Before going for A, B, C, D, don't look that. You take the 3 structures, write and think, then only you have idea. So let me go first one. Let me give that information. This is asked from the basic concept of chemistry, specifically under mesomeric effect. To understand reaction mechanism, there are 5 electron displacement effect: 1 inductive effect, 2 electromeric effect, 2 mesomeric effect, 3 hyperconjugation, 5 steric effect. So mesomeric effect is useful only for aromatic compound. So let me take now the 5, that is, I have already informed you: inductive, electromeric, hyperconjugation, mesomeric and steric effect is essential to understand mechanism. What is mesomeric effect? Because our question is asked under the aromatic, you must know. The permanent effect, whereby polarity is induced on the carbon atom and the substituent attached to it due to minor displacement of bonding electron pair caused by the electronegativity difference in a conjugated system, please follow, is known as mesomeric effect or resonance effect, simply represented by M effect or R effect. Kindly follow. Depending on the nature of groups attached, M effect may be classified as -M or +M. Please follow. What are the characteristics? You must know about that. Mesomeric effect is a permanent effect. It is operating in a conjugated part of a molecule, that is only in aromatic. Please follow. If it is aliphatic, it should be conjugation. It is usually represented by a curved arrow. There are 2 types, +M and -M. The effect is same throughout the molecule. Kindly follow. The effect is same throughout the molecule. Actually, I am giving the groups. Kindly follow, my dear student. This you have to memorize in order to give answer. This is +M effect. What is that? A group or atom is said to be +M effect when the direction of electron displacement is away from the group. From the group it is moving. Say for example NH2, kindly follow, there is a lone pair. So lone pair is donating that. It is moving, electron is moving from the group. Same way OH3 like this. But what is important duty? The order you have to. So NH2 greater than OH greater than OCH3, it is equal to this. NHCOCH3 greater than CH3 greater than X. Please follow. X, under the inductive effect, it will act as electron attracting group. Here it is acting as a electron releasing group. Please follow. The same way, -M effect. On the other hand, kindly follow. On the other hand, a group or atom is said to have -M effect when the direction of electron displacement is towards it. So electron coming towards the group. For example, suppose I have nitromethane. So what will happen now? This bond electron move towards NO2. Kindly follow. Same way cyanide, SO3H, CHO. This is the order you have to memorize. NO2 greater than Cn greater than SO3H greater than CHO greater than COCH3 greater than COH. So this order you have to memorize. This is the, please follow. Here one important information I will give this for you. All electron releasing groups are orthopara orienting groups. All electron attracting groups are meta orienting groups. Please note. Now let me come for the question now. Please follow. Here answer is given A. But if you say A means you cannot understand, let me explain clearly, you can understand. Just see, let me write aniline first. Please follow. This is the aniline, NH2. Second is para-nitroaniline. Para NO2 group, this is aniline. Then para-methyl-aniline. Para-methyl-aniline. Kindly follow. So, question is the correct increasing order of basic strength. So, we have to find out which is number one more basic, then second, third. So, when you compare these two, this is the standard. Aniline is standard. What is a base? Let me explain. A base is a substance which will accept H+, according to Lowry-Bronsted theory. Right. So, whereas when there is a NO2 group in the para positions, electron attracting groups, when CH3 electron releasing group, I have already given this. Kindly follow. NO2 minus M, CH3 plus M. So here you must understand, generally electron attracting group will decrease the basicity. Generally electron releasing group will increase the basicity. Please follow, let me repeat again. This is the sentence important for to identify the answer. Generally electron attracting group will decrease the basicity, whereas generally electron releasing group will increase the basicity. How? Kindly follow. This is NO2 lone pair is there. Because NO2 group it will attract towards the ring, will come here. So because NO2 group attracting, so lone pair that represents nitrogen atom going to the benzene ring. Up then go to the NO2. Whereas here it is electron releasing group, so moving here opposite direction, then going to nitrogen. So electron density will be higher in nitrogen. So number one, this. Number two, this. Number three, this. Now just find out the answer now. What is 1? Aniline. What is 3 is kind of the parameter. So 3 is more basic than number 2, that is 1 aniline, then 2 para-nitroaniline. I hope you have understand very clearly. So next I will go for the question number 5. Please follow. This is asked in NEET 2017. The IUPAC name of the compound is. So they have given India formula in this form. So there are 4 options are given. A, 3-keto 2-methyl X5-enol. B, 3-keto 2-methyl X4-enol. C, 5-formyl X2-en 3-one. And D, 5-methyl 4-oxo X2-en 5-IIL. My dear students, let me give this. This is the question asked under the basic concept of chemistry, specifically nomenclature under IUPAC name. So, under the IUPAC, my dear students, when you see my chapter, basic concept of chemistry, under the naming, I have clearly mentioned about IUPAC. IUPAC, because this method of discussion is not given any book. Only I am giving this way. Type 1, type 2, type 3. What is the meaning of type 1? Type 1 nothing but alkane without any functional group. Type 2, one functional group present. One functional group. Type 3, more than one functional group. So this is the type 2. Kindly for type 3, kindly follow. So there are separate rules for type 1, type 2, type 3, and we have to study. So apply that rule, then we have to give name. We will not do any mistake. And for that, what you need, please follow. So this table is not normally given in your textbooks. This is taken from the MSc book. Kindly note this one. The interesting information here is, kindly follow. Okay, that is one table is missing. That kindly, my dear students, that is only, it is starting from 6 only. So number 1, carboxylic group. Number 2, the corresponding anhydride. Number 3, the ester. Number 4, the correspondingly halide. And number 5, the correspondingly amide. Please follow. So these acid and acid derivatives 1 to 5 it is occupying. So I am giving here from the 6th onwards I am giving. So 6 nitriles, group CN, suffix nitrile, prefix cyano. Aldehydes, CHO, suffix AL, prefix formyl. And ketones, CO, suffix ONE, prefix OX, oxo or keto. 9 alcohols, OH, OL, then hydroxy. Then coming for the next one, mercaptans, SH, thiol, mercapto. Amides, NH2, no, there is no suffix, only prefix amino. But rare cases, the primary members we can use amine, methylamine, ethylamine you can use. The next comes alkenes, suffix ENE, prefix alkenyl. Next alkynes, C triple bond C, YNE, alkynyl. Then 4 ethers or there is no suffix alkoxy or oxa. Halides minus X, the dash halo. Nitro compounds NO2, no suffix, only prefix nitro. Alkanes R and alkyne. So this is called seniority table. You have to memorize. Only if you memorize that, if more than one functional group is present, you can follow the order. Here I will give the tricks. Kindly follow. You first find out this compound. How many functional groups we have? We have 2 functional groups. One is CHO, another is CO. From the seniority table, CHO takes priority. Kindly follow. When CHO takes priority means we have to use suffix only for this. And we have to use prefix for this one. Kindly follow. Then according to this is coming under the type 3. So we have to select the longest chain containing all the functional group. So I am selecting the chain, kindly follow. Starting the chain here, it is going like this, it is here. So I am CHO1, this is 2, this is 3, this is 4, this is 5. So it is 5 carbon atom. Kindly follow. CHO1, CHO 1 carbon atom, then this is 2, then this is 3, keto 3, this is 2 methyl group, this is the methyl group. Then double bond is present here, 1, 2, 3, 4th carbon atom, double bond is present. So how can you find out now? How many? 1, 2, 3, 4, 5, 6. It is the parent is hexane. Please follow. Parent is hexane, but double bond is present. Instead of hexane, I will use hexene. Kindly follow. Hexene. Okay. Then the terminal suffix is CHO. So I am removing E. I am adding AL for the corresponding aldehyde. So numbering I have to start from here. I told you 1, 2, 3, 4, 5 and 6. So automatically in the 2 position there is a methyl group. 2 position. In the 3rd position there is a keto group. Kindly follow. In the third position, we have keto group. Kindly follow. So now just see so correct answer is B. What way? Kindly follow. 1 to 3 keto, 2 methyl, X, 4 in AL. And if you want to specify even, you can write 1 AL. There is nothing wrong. That is one not necessary. So this is the way we have to name the compound. Please follow. That's why the seniority table you have to memorize. Question number 6. This is asked again in NEET 2017. With respect to conformers of ethane, again this question related with confirmation. Which of the following statement is true? Which of the following statements is true? Statement is true. Kindly follow. Now, kindly follow me. There are 4 statements are given. A, both bond angle and bond length remain same. Both angle remains same but bond length changes. Both angle changes but bond length remains same. Both bond angles and bond length changes. Let me introduce the what topic it is. Again, it is based on the basic concept of organic chemistry under confirmation. Please follow. What is the correct answer? This is the representation. We have seen already. Staggered is more stable than the eclipse. So here the important information here is answer A is the option A is the correct answer. Both bond angle and bond length remain same. Remain same. They will not change. Kindly follow. Okay. The next question. Question number 7, asked in NEET 2017. The correct statement regarding electrophil. Please follow. Electrophil is A. There are 4 options are given. A. Electrophil can either neutral or positive charged species and can form a bond by accepting a pair of electrons from a nucleophile. B. Electrophil is a negatively charged species and can form a bond by accepting a pair of electrons from nucleophile. C. Electrophil is a negatively charged species and can form a bond by accepting a pair of electrons from another electrophil. D. Electrophils are generally neutral species and can form a bond by accepting a pair of electrons from nucleophile. Please follow. This is the question asked under the basic concept of chemistry, specifically under reaction mechanism. Please follow. Under heterolytic reactions, kindly follow. Let me explain that one. So chemical reaction based on nature of attacking reagent, we can classify 2 ways. One is heterolytic reaction, another is homolytic reactions. So homolytic reaction only free radical will give, so we are not interested. So we are interested only here heterolytic reaction. A simple example. For heterolytic reaction, let me take example of, please follow. I take propene plus HBr addition reaction, let I am taking. So what will happen now? HBr will cleave in the form of H plus and Br minus. Br minus. So H plus is called electrophil, Br minus is the nucleophile. So then you will add. So this is electron releasing group. This will shift the electron like this. Everything we will see, we have discussed. This is plus, this is minus. So automatically plus will go here, minus will go here. It will form 2-bromobutane. Now, let me come for this. So this heterolytic reaction not necessary for us. Only we need homolytic reaction. Kindly follow. Heterolytic reactions is one where attack reagent undergoes electrolytic fission to produce ion. These ions are called electrophils or nucleophiles, and the reaction is also known as ionic reaction. Suppose 2 chlorine atom undergoes cleavage, Cl plus Cl minus. Electrophil, nucleophile. Please follow. Now, how to define electrophile? Electrophile may be defined as a species which may be neutral or positively charged. Please follow. May be neutral or positively charged, having affinity towards electron. Neutral electrophile example, boron and aluminum chloride. All the boron family the compounds will be the electrophils. Positive charged electrophils, H plus, Cl plus, lithium plus, all plus will be again electrophil. So it may be neutral or positively charged. Please follow. So nucleophile, just opposite. Nucleophile may be defined as a species which may be neutral or negatively charged, having affinity towards nucleus, that is proton. Neutral nucleophiles, water and ammonia. Negatively charged, Cl minus, OH minus. So now we will come for our question. Kindly follow. So now you have clearly understood the concept. What is the correct statement here is A. Electrophile can either neutral or positively charged. I have explained clearly. Species and can form a bond by accepting a pair of electrons from a nucleophile. Very clearly we can understand this question. Then question number 8. My dear students, kindly follow. This again asked in 2008, NEET 2017. Which one is the most acidic compound? We have seen already basic compound. This is acidic compound. Now it's very clear. A, kindly follow. It is 2, 4, 6 trinitrophenol. B, paramethylphenol. C, phenol. D, the correspondingly paranitrophenol. Which is more acidic? The question is asked. The question is again under the basic concept of chemistry, specifically reaction and mechanism, that is under mesomeric effect. Mesomeric effect applicable for aromatic compound. Let me explain now, kindly follow. So all the explanation not necessary I have to repeat again because this I have already explained. I will come directly the questions. Because I need not repeat again what are the mesomeric effect, everything. I have explained the previous case. So in this case, what we have to do, now see here, which is more acidic. The phenolic group is an acidic compound. Phenolic group, that is phenol, is acidic in compound. Kindly follow. This OH, because the phenyl group, again oxygen, along with phenoxy group is attracting group. Attracting this hydrogen will go in the form of H+. So acidity. Kindly follow. So you see is the standard. I have already informed you in the case of, that is bases I have given. Now in the case of acid, please note my dear students, generally electron attracting groups will increase the acidity. Please note my dear students, generally electron attracting group will increase the acidity. Generally electron releasing group will decrease the acidity. So in this case, kindly follow, this is the standard. Okay. Then I am taking A is the correct answer. Reason is there are 3 NO2 group, 2, 4, 6. So more, 3 means so highly acidic. This is number 1. Then just see here methyl electron releasing, so it's less acidic. So this is number 2, paranitrophenol number 2. Then this is number 3, this is number 4. Kindly follow. So what I am going to arrange now, which is one the most acidic compound, A is the most acidic compound. What is the order now? 1 greater than 2 greater than 3 greater than 4. This is the order. 1 is the most acidic compound because 3 nitro groups, the nitro groups are attracting groups will increase the acidity. Understand this, a common name is picric acid. Common name is picric acid. The only acid without containing carboxylic group in organic is the picric acid, that is called 2, 3, 2, 4, 6 trinitrophenol. So this is the correct answer. So I have come to the conclusion, my dear students. Thank you very much for the kind cooperation you have given for me. So if you are the first beginner, you are first time seeing my video channel, NEET Chemistry by Dr.R.G. My dear students, I will be very much thankful to you. I request you kindly Click like, click subscribe button and share with your friends. And also, why I have started this channel? During the pandemic last 2 to 3 years, I was sitting simply in the house without doing any work, without going outside. So I want to utilize this time, enormous time, 3 years. So why can't I can start a channel so that to help the poor students of India, specifically my subject chemistry. So that's why I given the channel name NEET Chemistry. So here I have discussed entire chapters from 8th, 9th, 10th, 11th and 12th chapters. Now I am started discussing question under the each unit. Here I am not only going to discuss NEET. After this I will take IIT, I will take AIMS, I will take NEET, the MSET Andhra, I will take AIPMT, etc. It will take minimum 1 year for me. Anyhow, this I am doing only the welfare of poor students of India. So if you follow me, my channel, I can give guarantee you will get 100 out of 100 marks in our board. If you go for NEET entrance examination, 180 out of 180 you will get. I can give guarantee for you. But you have to follow properly, take notes, everything, systematically, everything. So the another part I want to give, this is the information for students of +1, +2 and +2 completed students. So I am running a coaching center in Pondicherry, Vetri Coaching Center for the last 21 years. Since 1999, we had a lot of achievements. If we have our own website, Vetri.S. If you enter our homepage, you can see our achievement in terms of photograph. Each and every year, how many students cleared for JIPMER, joined JIPMER and other colleges, everything will be given there. Kindly follow. The most important achievement I want to give, one of our students, R. Srinivas Raghavan, in 2003 came All India first rank in JIPMER entrance examinations conducted by JIPMER Institute. At that time, NEET and the Common Entrance Examination was not there. JIPMER was conducting separately for the entire India. So he came out of more than 10 lakh students, he came first. So that is our achievement. Another achievement is every year, Pondicherry first rank, except 1 or 2 years, out of the 21 years, except 1 or 2 years, first rank already only taken by our students. The most important among them all, regularly, every year, minimum 10, maximum 20 or 25 students are joining from Vetri, through Vetri to JIPMER medical colleges. 150 to 200 students are joining other medical colleges through the government quota by merit. A few students are joining IIT, hundreds of students are joining other engineering colleges. This is our importance of Vetri Coaching Center. Now let me come for Vetri.S, our website. Now in the pandemic condition, this is very good for you. For good students, if you follow Vetri.S, it is very cheap, only 10,000 rupees for whole year. Only 10,000 rupees for the whole year I am charging. So what is the important feature of this NEET, the Vetri.S, kindly follow. It is having 200 video lesson, 200 unit test. Coming for video lesson, all the video lessons were taken by professors with a doctorate degree and 20 to 30 years of experience in teaching IIT and medical coaching. Also teaching BSc, MSc and MPhil PhD. So when we are doing the video lesson, you can feel the classroom coaching. You can see the board, you can see the teacher, he will write, you can see the teacher, you can see the board, everything you can see like a class atmosphere. And another most important is, just like in YouTube, this video will be full of lesson, full of your informations, definition, formula, everything structure, everything table of column, everything will be there, diagram. So if you want, just touch the video, it will stop, you can note everything. Then touch again, it will run, just like YouTube. Please follow. We have programmed such a way this is happening. This is our own software. is the software is done by the eminent the programmist, that is G. Ganesh. Then coming for 200 unit test. Listen me, 200 unit test. Each unit in each subject we have two tests. For example, this is the basic concept. Under the basic concept, I have two tests, test 1, test 2. Each one having 45 questions. Please follow. So, if you enter into the home page, Vetri.S, you click Vetri.S in Chrome, our site will enter, register, then log in, our site will open, then go for NEET free, it is their option, and then go there and go any subject. There is a free lesson, you can see, free test you can write. So let me explain what way test you have to write. Kindly follow. If you go and click the basic concept of chemistry, immediately a window will open. In the window, it will be, this unit contains 45 questions. One of the options, 4 options will be there. Only one option is correct. Each question carries 4 marks. For correct answer, 4 marks. The wrong answer, -1. Are you ready? It will ask. If you click OK, take your rough notebook and pen and start ready. Click the button OK, a window will open. You can see the question 1. Option A, option B, option C, option D. There is a clock is there, and there are 3 menus. And here below there are 1 to 45 question number will be there. Question number will be there. Please follow. This facility is not available any online leading coaching center in India. You compare. Please compare. So when you are seeing the question number 1, kindly follow. The time starts from 45 minutes going down. There are 3 menus. Center is complete. Right side is next. Left side is reverse. You can go forward, you can go backward. And also there is 1 to 45 question number will be in yellow color. This is for your self-assessment. To save time. Kindly follow. What way? Suppose you are assuming A is the correct answer for question number 1. So click A, immediately in question number 1 becomes yellow color changing to green color. Question number 2, yellow changing to blue, other questions will be in yellow color. The meaning is, green you have attended, blue you are going to attend, then all the yellow, that is you have to attend in future. So then in the systematic way, you go 1 to 45 questions. After completing all the questions, click complete. Then window will open. In the window, you can see the marks. 140 by 180, let us assume. That means you are losing 40 marks. You want to know where you have done mistakes. Kindly follow. This facility is not available in other online question, leading question online site. Only in Metri.S we have. How? There is a menu called review. Review. Next to mark. You press review. What will happen? Now a window will open. In the window, you can see question number 1. And option A, option B, option C, option D will be there. And correct answer will be given in yellow color. And below that, there is a video solution. Video solution. Please follow. Since you have answered question number A is the correct answer, it will be in blue color. Correct answer will be in yellow color. So you compare your answer blue with the correct answer yellow. Both are same, your answer is correct. If they are different, your answer is wrong. Some cases, rarely, occasionally, your answer may be wrong, correct, they have typed wrongly. You need not worry, go video solution, professor will give you the correct answer. Because it's only a typed thing, 1 or 2 exception may be there, mistake may be there. Anyhow, don't worry about that. You compare with the video solution answer. 100% there will not be any mistake. Kindly follow. So, you can, suppose, for after 20 minutes, what you can see, out of 45, how many questions you have attended, you can see by the green. How many questions you have to attend, you can see as a yellow. So, according to that, you can adjust your time. So, everything is over. Kindly follow. Just click video. Wherever you have done mistake, then you have video solution taken by the professor with the doctorate degree and experience. So just like what way I am taking class now, look at the questions, the same way it will be video solution. Minimum 5 to 15 minutes it will be. I hope, my dear students, I have come to the conclusions. So how to pay 10,000? This is for 1 year charge. Please follow 1 year charge for 4 subjects. Pay 10,000 in the name of Santi, Director Vetri Coaching Center, in the account Indian Bank account number 7127194771. IFC code IDIB000P134, cell number 989417645. WhatsApp number also. I hope I have come to the conclusion. Thank you very much for the kind cooperation. See you again in my next topic. Bye bye.